All right, so the first one, it just says to divide, but we cannot use synthetic. Why not? Because it's x squared. Synthetic has to be x plus or minus something. You can't do it with the x squared. So I'm going to do long division. This first, the dividend is in decreasing degree. There's nothing missing. But on the divisor, there is. We're missing the x term, so we have to make sure we add in that 0. So I'd get x to the 4th minus 2x to the 3rd plus x squared plus 2x minus 8 divided by x squared plus 0x minus 3. And then it's first into first. So if I divide x squared into x to the 4th, I get x squared. I'm going to multiply that times each term on the outside. So x to the 4th, 0x to the 3rd, negative 3x squared. I'm going to change my signs and add. This cancels. Negative 2x to the 3rd plus 4x squared. Bring down the positive 2x. Repeat that process first into first. So what would I have to multiply x squared by to get to negative 2x to the 3rd? Good. So now I'm going to multiply negative 2x times x squared is negative 2x to the 3rd. Negative 2x times 0x is positive 0x squared, or negative 0x squared, doesn't matter. Negative 2x times negative 3 is positive 6x. Change your signs. This cancels. 4x squared minus 4x. Bring down the minus 8. Repeat the process again. This time it's x squared into 4x. So positive 4. Multiply it. 4x squared. Multiply it. 0x. Multiply it. Negative 12. Change your signs. Cancels. Negative 4x plus 4 is your remainder. So I get a quotient of x squared minus 2x plus 4. And then my remainder, if I add it, the negative stays on the 4 up here. It would look like this. If I take that negative out, I'm basically taking it out of the entire expression. So if I put the minus here, I have to change both the negative 4x and the positive 4. And my answer would look like that. If this was an open-ended question on a test or quiz, I would actually take either of these, okay? Just be careful. If it was multiple choice, the negative would probably be taken out, okay? And if you take out the negative but not take it off the 4, now it's wrong. So just be really careful. Questions? Yep. All right, number 2, use synthetic division to find and the remainder theorem to find the value of f of 2 for the function. What does all that mean? What does it mean to do? What does it want you to do? Synthetic division with what on the outside? 2 goes on the outside. So 2 goes on the outside. This is in decreasing degree order. Nothing's missing. So write the coefficients. 1, 1, negative 11, and 10. Bring down the 1, multiply by 2, put it in the next column and add it. Multiply by 2, put it in the next column and add it. Multiply by 2, put it in the next column and add it. So the remainder is 0, which means f of 2 is 0. What else does that tell you?
It's a real function.
Yeah.
It's a factor.
What's a factor?
2.
2 is a root or a 0 of this. X minus 2 would be a factor of it. Okay. Questions? How did we do on homework last night? Good? Any questions? Okay. We're going to finish the notes. 4, 2, 3. Yeah. All right, so what happens if you don't have any of your roots, okay? You have to find your bank of possible rational zeros. To do that, you put all the factors of the constant over the factors of leading coefficient. So you want your expression to be in order of least decreasing degree. And it was plus and minus all the factors of the last over all the factors of the first. From there, you're going to use synthetic division to find one of the rational zeros that works, and you will know it because the remainder will be 0. If you started with an x to the third and then you use synthetic, it will reduce it to x squared. And on those, you can either factor or use the quadratic formula. If you started with x to the fourth and find one that works, you reduce it to x to the third. Maybe you get lucky and you could factor by grouping from here. But if not, you have to reduce it again by finding another 0. And then it becomes x squared, and that you can either factor or use the quadratic. So this again is if you have nothing to go on. All right, so it says list all the possible rational zeros of the function, find one zero of the function using synthetic division, find the remaining factors of the polynomial, what are the zeros of the function, and how did the graph below help you find those zeros? So we're starting with possibles. I'm checking to make sure this is in order of decreasing degree. It is. So my last term is 12. This is the last, obviously. My first is the coefficient there, which would be 1. What are the factors of 12?
1, 3, 4, 3.
The order in which you're doing this is so interesting. 1 and 12. Then 2 and 6. Then 3 and 4. You were all right. It was just a very interesting order in which you did that. Okay? Those are all the factors of 12. Those are all going to go over all the factors of the first term. What's the first term? 1. We're going to go easy in the beginning. There's only one factor there. If that number was 2, I'd have to put all those numbers over 1, and then I'd put all those numbers over 2. We'll talk about what that looks like in a second. And it's plus and minus, which means my possible roots are -1, +1, -2, +2, -3, +3, -4, +4, -6, +6, -12, +12. So I think on WebAssign at one point it says literally list them all. You have to list them like that. If this was on your test, you can give me the plus or minus, but it can't be over 1 anymore. It has to be plus or minus 1, 2, 3, 4, 6, 12. You have to at least simplify to there. All right, now we test them out. So let's pick. Let's start however we want to start. We could start with the positive ones. We could start with the negative ones. It doesn't matter in which order you do this. Pick a number from that range. 3? Okay. We're going to try 3. We're going to put 3 on the outside. 1, -3, -4, 12. Bring down the 1. Multiply it, put it in the next column. Add it. Multiply it, put it in the next column. Add it. Multiply it, put it in the next column. Add it. Aiden's looking pretty smart right now. Because he picked 3. How'd you know to pick 3? Oh, liar. Really? I mean, you're not a liar. Sorry. I'm sure you just guessed. But this guy, right? The graph would have helped us. We're going to pretend like we didn't have the graph, though. Okay? So if I had tried 1, it would not have worked. If I had tried -1, it would not have worked. If I tried 2, it would have worked. So I would say normally we go in a pattern. There are some tricks I'm going to teach you at the end to help you eliminate some. But we got lucky, and we picked one that worked the first time. So 3 is one of my zeros. Now, it's because that's my remainder. Now I'm going to take my reduced degree, which the -4 is my constant. This would get my x, and this would get my x squared. So what's left is x squared minus 4. I'm going to see if I can factor it. Can I factor it? Yeah. How do I factor that?
X minus 2 times x plus 2.
Good. And then split and solve. And I get my remaining roots are 2 and -2. If it was not factorable, I have to use the quadratic formula. Now it asks for all the zeros. So these are all my zeros. 3, -2, and why did I write 3 twice? 3, -2, and 2 are all my zeros. Then it says, how would the graph below have helped you find those zeros? If I look at this graph, each of these x-intercepts match the zeros, okay? That would only work if they are all real zeros, first of all, because you can have imaginary zeros in here. Okay, and it would only work like if they're nice even numbers, because you can also get square roots involved in here. You might get fractions. Okay, we're going to play with those a little bit and see what would happen then. Okay. All right, Descartes' rule is something that can be used to help you narrow down your bank of possible roots. Okay, and Descartes' rule says that if you have your function and it is in decreasing degree order, that's what all that notation at the top says, because if this is the highest exponent and this is one less than that, and you would keep going until there was no exponent, that means decreasing degree order, then the number of positive real zeros can be found by counting the number of sign changes. So if it goes from positive to negative or negative to positive, that is a sign change. You literally count them. That's the most amount it can be. It can also be that number minus a positive even integer. What's a positive even integer? 2, 4, 6, and so on. So if I count my sign changes and there are 4 sign changes, then there are either 4 positive real roots, or subtract 2 from it, 2 positive real roots, or 0 positive real roots. So if that, whatever that number is, you take that number, and then if you can subtract 2 from it, you continue to subtract 2 from it until you hit 0 or a negative number, because you can't have a negative number of real roots. If I counted 3 sign changes, then there are either 3 or 1 positive real roots. Now these can be fractions, these can be whole numbers, these can be square roots. They are real, however. The second one says the number of negative real roots, or real zeros, is the same as the number of sign changes of f negative x. What that means is I'm going to plug negative x in for x, and then I'm going to count. And same, count the number of sign changes, and then every positive even integer subtracted from that. So same rule. If I count and there are 2 sign changes, thank you.
These are for all of you.
Okay, or 0. Okay, so again, if you can subtract the number from there, an even integer, okay, then you subtract it. So basically just keep subtracting from 2, subtracting 2 until you hit 0 or you hit 1, because then you'll know to stop. So think about why this would be helpful, okay, because it's a weird thing, right? So like, why is this helpful? If I, for example, let's say I count my sign changes on the positive ones, and there is 1. It's not that there are 1 or something else. There is 1 positive real number that's going to work. Now I go to my possible bank. Out of all of my possible banks, what am I going to try first? The positive ones, because one of those has to work. Does that make sense? Yeah. If I find that it is 2 or 0 and I find 1 positive root that works, what else do I know? If there are 2 or 0 and 1 already works. There has to be 2. So I know when I look at my answers, 2 positive numbers have to be there. Does that make sense? So there's going to be a question that just blatantly says, use Descartes' rule to determine the number of positive and negative real roots. And you'll literally do this. And then there are times in which you can use it to reduce your possible bank. That would be the benefit of it. All right, so if you just look at this one, okay, in that first polynomial, go through and they already counted your sign changes. So it goes from positive to negative, that's 1. Then it stays negative, and then it goes from negative to positive. There's a second sign change. It stays positive, but then it goes to negative. That's a third sign change, which would mean there are 3 or 1 positive real roots. If you go to the second one, you count the sign change. It starts positive, stays positive, becomes negative. That's 1 sign change. goes back to positive, that's a second sign change, stays positive. That's 2 sign changes, which means there are either 2 or 0 positive real roots. And then the last one, it starts negative, it changes to positive, it stays positive. There is only 1 sign change, which means there is 1 positive real 0. If I wanted to do this for the negatives, I'd have to go in and replace all those x's as negative x and then find it. We're going to do that here. For example 9, for the polynomial, how many positive and negative zeros are there? Use the graphing utility to find 1, and then what are all of them? So we're going to start with how many. So if I start positive and I switch to negative, that's 1 sign change. I stay negative, I switch to positive, that's a second sign change. So there are how many positives? 2 or 0 positive real roots. Then I'm going to plug in my negative x. So negative x to the third minus negative x squared minus 4 times negative x plus 4. Negative x to the third is negative x to the third. This becomes positive x, but the minus is still out front, so minus x squared. Negative 4 and negative x is positive 4x plus 4. So my sign starts negative, changes to positive, stays positive after that, which means there is 1 sign change. And there is 1 negative real roots. Good so far. Now it says use a graphing utility to find 1 real 0 of the function. I'm going to do that. I'm going to go to my graphing utility. I'm going to plug in x to the third minus x squared minus 4x plus 4. And I'm going to hit graph. All right, so here's my graph. How can I check for my real roots? I've got options, yes. Which one?
Trace.
I could trace it. And you mean find your zeros? Like second, trace, 0. I could find any of them, right? First of all, I knew there was a negative because it said there was 1 negative. So let's double check that negative. And it's going to bring you to it, which is -2, okay? This time, they are all whole numbers. I could literally see them from my graph or go to my table, not alpha, table, and look for my zeros. How would I know something's a 0 here? The y is 0. So there's 1 at 1, there's 1 at 2, and the last one was at -2. Sorry, my steps are small. I didn't put it back after the -2. Okay, so all those are ways to check your zeros. On your test, you will be given a graphing calculator portion in which you are going to have to find your possible banks. You're going to give me the whole possible list. You're going to use your graphing utility to find at least one of those roots. That root is not going to be obvious. That root is not going to be a whole number. You're going to have to use your trace feature, okay? But let's say it's like a 1/3. When you look at your roots, you should see a 0.3333. That should make sense. If you go to your possible banks, that means it's 1/3. Then you're going to use that root to reduce your quadratic a degree, which we're about to do, or your cubic a degree, and then you'll find the remaining roots from there, okay? So that process would look similar to what we just did, except that they will not be, God bless you, all whole numbers. You'll find 1 from here. So we're going to say we found the -2 from there. We got x was -2. That's one of our real roots. That was our only negative real root. Now I would reduce it a degree by putting the -2 on the outside, listing my coefficients, 1, -1, -4, and 4. Bring down the 1, multiply it, put it in the next column, and add it. Multiply it, put it in the next column, and add it. Multiply it, put it in the next column, and add it. If I don't get 0 there, then I did something wrong. I grabbed the wrong root. It has to be 0 if it's a 0. The remainder has to be 0 if it's a 0. Now, that's my remainder. I take what's left here, x squared minus 3x plus 2. And you're going to either be able to factor this or solve it using quadratic. I would put it in parentheses, x minus 2, x minus 1, split and solve. X equals 2 and x equals 1. So all of the zeros would include negative 2, 1, and 2. Now this one was factorable from the get-go. You could have actually factored by completing or by grouping. It will not be the case on your test. Yep.
Wait, the negative one I really didn't understand. I understood everything else, but like with the negative, like how is
The one real root, you mean?
Yeah, the
This
one real negative.
this part?
Yeah.
So you're going to take your function, which was here. I'm going to plug in negative x into all the x values. Simplify it. So negative x to the third is negative x to the third. Minus a negative x squared. The negative x squared becomes positive x squared, but there's still a minus here. So it's minus x squared. And then negative 4x times, or negative 4 times negative x is positive 4x. And then the positive 4 stays. Then from here, we're going to count our sign changes. So it started negative, stayed negative, switched to positive. That was one sign change. Stayed positive. So one sign change means one negative root.
Okay, so you make all the x's negative.
And then you count your sign changes again. Yeah.
I understand why there could be two possible roots, but why is there also 2 or 0?
Because the other, this is a really good question, and we'll talk about it more tomorrow, but those other real roots could be imaginary. And imaginary roots come in pairs.
Just always say 2 or 0.
So it's, and if it was 3, it's 3 or 1. You subtract 2. If you counted 7 sign changes, which would be so very fun.
7 or 5.
7 or 5 or 3 or 1. You keep subtracting by 2 until you run out of numbers.
So if it was 1, would it be?
It's just 1. You can't have a negative amount. Yeah. All right, the last thing is called lower and upper bounds. And again, this is just a tool to help you narrow down your possible bank. The lower bound means it's the lowest possible root. There's nothing lower than it. And the upper bound is the highest, meaning there's nothing higher than it. The way you test this, and it only works if the first part of this works. So if C is greater than 0, so C is positive, or whatever you're putting on the outside of your synthetic division is positive, okay, that's your C. If C is positive and you divide synthetically, and the last row, the bottom row here, is either all positive or all 0, or a combination of positives and zeros, then that number is an upper bound. It does not mean it is a root. It just means nothing bigger than that is a root. If the C is negative, and again, you put it on the outside and you divide synthetically, and the numbers on the bottom here alternate positive and negative, and a 0 could count as either. So it can go positive, 0, positive, and that would count as alternating. Then again, the 0 is not necessarily a 0 unless it has a remainder of 0. But what it does tell you is that it's a lower bound, meaning don't try anything smaller than this. They won't work. So it narrows down your possible banks, okay? So we're going to go into one. The instructions here just say use synthetic division to verify the upper and lower bounds of the real zeros, but then I'm going to talk to you about how this would help you with your bank too. So first of all, it says here's my function, okay? And it wants you to prove that x equals 1 would be an upper bound. So the 1 goes on the outside. I don't change the sign because it's not x plus 1. It is x equals 1. I make sure all my coefficients are there. Nothing skipped. They are, so I list them out. And I divide synthetically. Bring down the 1. 1, 4, 4, 2, 2, 3. Now, is 1 a root? No, because my remainder is not 0. But look at all these numbers. They are all positive. They have to be all positive or 0. And what that tells you is that this is an upper bound. And an upper bound means if there was other numbers in this bank that were bigger than it, it can't happen. Don't even waste your time trying them. B says lower bound. Notice it's negative. It only works if it's negative for a lower bound. So the -4 goes on the outside. Same numbers, 1, 3, -2, 1. Bring down the 1. Multiply it by -4, put it in the next column, add it. Multiply it by -4, put it in the next column and add it. Multiply it, put it in the next column and add it. Wait, this should be -8, sorry. And notice these are alternating. That proves -4 is the lower bound. So if there was anything in my bank lower than -4, I would not try it because it doesn't work. So your test is not going to ask you specifically to identify an upper bound or a lower bound, but if you are trying possible roots, that is your way of narrowing it down. If you are dividing and you're testing it out and you happen to get something that's all positive or a positive and zeros, now you know that there can't be anything bigger than that number that works. So you wouldn't try anything bigger than that number, okay? So if I look back on 9, let's say, for example, that I had picked from my possible banks 2. And I had worked out, actually, let's look at -2 because that's the one we used. I used -2 and look at the pattern here. It went positive, negative, positive, and 0 counts as either. That is alternating positive and negative. That tells you -2 would have been a lower bound. And if there was any other root in here in our possible bank that was less than -2, I wouldn't even waste time trying it because it's not possible. That's how you can use lower and upper bound. Questions? Yeah.
On the test, does it read like questions like that? Or?
It's not going to ask you lower or upper bound, but you're going to have to test points from a bank.
Okay, so we kind of have to do.
You just use it to help you. Otherwise, you have to plug in more points. That's all. Yeah. If I wanted to find the possible roots for this, because the one that we did only had was 1, right, for the leading coefficient. The last term is 6. What are the factors of 6? 1, 2, 3, 6. The first one is 4. What are the factors of 4? 1, 2, and 4, right? 1 and 4 and 2 and 2. So when you're finding all the possibles, it's plus and minus all of these over all of those. So I put all of these over 1 first. God bless you. 1 over 1, 2 over 1, 3 over 1, 6 over 1. Then I put all of these over 2. 1 over 2, 2 over 2, 3 over 2, 6 over 2. And then I put all of these over 4. 1 over 4, 2 over 4, 3 over 4, 6 over 4. And then I simplify. So this is 1, 2, 3, 6, 1/2. This is 1. I already have it. 3 over 2. This is 3. I already have it. 1/4. This is 1/2. I already have it. 3/4. And this is 3/2. I already have it. So this, with a plus and minus in the front, is your possible banks, okay? If the leading coefficient is not 1, you got to put them all over each of the terms from the first one.
If we have